Okay, today we're going to talk about solving for a variable with multi-steps in the problem. And before we begin, let's review a couple things. When you're solving for a variable, and we'll do several examples in a moment, there's some important things you want to remember. The first one is very, very critical that order of operations is followed. Now, this is where a lot of mistakes are made, either because somebody is in a hurry or they're not paying really close attention to things like minus signs and parentheses. So you want to make sure that on both sides of the equal sign that you perform all of the operations that are called for on each side of the operation sign: multiplication, division, if there is that, addition, subtraction, and also pay very close attention to the effect of the multiplications and the parentheses on minus signs. That is one thing we want to make very, very clear. The next thing you want to do is you want to carry out the collection of terms and the order of operations on each side of the equal sign. So do everything, do all steps on each side of the equal sign. First, and then the third thing is to collect all terms. And it doesn't really matter whether you collect the variable terms on the left or the right. You can solve it either way. So you want to collect all the variables on one side. So we'll just say variables on one side. And the numbers on the other. Now when I say variables, I'm including the coefficients, such as like 3n or 5n, something like that. So now keep in mind, we'll just review for a second here before we move on to the examples, and that is if there is an equal sign, okay? And this is something we learned early, that the equal sign indicates that there is something to be solved for. If there is no equal sign and you just have a collection of numbers and variables, you are meanly simplifying an expression. You're not actually solving for the variable. Only the equal sign indicates that there is something that you should be solving for. Okay, so that's just a quick review of that. Okay, so let's look at some examples, and what we'll do is we'll just work them step by step as we go along. So the first one here is a pretty simple case. 13 plus 7x equals 5x plus 3. And let's go ahead and start out by collecting all the variables on the left side and the numbers on the right side. Now in this case, there are no parentheses, and on each side there's not multiple different terms to add and subtract. So what we can do here is, and I'm going to go through steps, even though a lot of this can be done in your head when you get used to it. But first thing let's do is let's get all the variables on the left. So to get all the variables on the left, we're going to subtract 5x from this side. We're going to subtract 5x from this side. Remember, this is one of your key rules of any kind of equation or solving of an equation. Whatever you do to one side of an equation, you must do to the other. And so in this case, we're going to move this 5x, basically move it from the right to the left. The 5x and 5x cancel out and gives us nothing. Well, let me, I don't want to put something down there that looks like it might be a variable, but this would be basically a 0. And then the 7x plus the minus 5x, or 7x minus 5x, is 2x. Okay, so we're left with 13 plus 2x equals 3. Now what we can do is we can subtract 13 from both sides because we want all the numbers on the right. So in order to get rid of the number on the left, we'll subtract the 13, and we'll subtract 13 over here. And so again, this will go away, and we will end up with a 2x by itself equals 3 minus 13. Well, that gives me a minus 10. And then we can divide both sides by 2. And so what happens when we do that? We'll get that, and we'll get x equals minus 5. Okay? Let's look at the second one over here. Now we have introduced a parentheses into the problem, which adds one step of complication here, but not a particularly significant one. So let's see what we've got. So we've got 2 times 5a minus 2 in parentheses plus 7 equals 27 minus 2a. First thing we want to do, again, is follow the order of operations on each side. On the left side, we do have to distribute through a parentheses. So let's just go ahead and do that. So 2 times 5a gives me 10a. 2 times minus 2 is minus 4 plus 7, I just bring that down, equals 27 minus 2a. Okay, now we're in a place, there's one step we can do here to simplify the left side. We'll collect the like terms on the left side, and we'll get 10a minus, or plus 3, actually minus 4 plus 7 is a plus 3 equals 27 minus 2a. Okay, now we're at the point where we're down to a single term on each side of variables and numbers. So again, let's tell you what let's do. Let's go ahead and regroup these in such a way that we get all the variables on the left and all the numbers on the right. So if we want all the variables on the left, we have to get rid of the minus 2a on the right. So what we'll do there is we'll add 2a. We'll add 2a to the minus 2a, and that will take that away. And then, we'll, of course, we have to add the 2a on this side. Okay, so when we do this, this side becomes 0 for the variable, and this becomes 12a. So we've got 12a plus 3 equals 27. Okay, and now what we'll do is we want to get rid of this 3 on the left side because we want all the numbers on the right. So we'll subtract 3 from both sides, and we will get 12a equals 27 minus 3 is 24. And now we can divide both sides by 12. And we will have a equals 2. Okay, and I got squeezed here at the bottom, but a equals 2 is the answer to that one. Okay, so let's move on to, as we go along here, we're going to get just a little bit more complicated each time. I have to try to be a little neater, perhaps. So we have minus 8n minus 8 times, in parentheses, 6 plus 5n equals minus 8 times, in parentheses, 8n plus 8. This is a good example. We just have to watch our minus signs. And again, let's work on, first of all, let's work on the left side and perform the order of operations. So let's take this one. It's going to be minus 8n, and then minus 8 times 6. That gives me minus 48. And then minus 8 times 5n gives me minus 40n. Okay, now we've pulled that out of the parentheses by distributing it, and now that's going to be equal to minus 8 times 8n is minus 64n. Minus 8 times a plus 8 gives me minus 64. All right? And so now we are in a position where we can begin to collect terms again. First thing on the left, we have two terms that deal with the variable, which is minus 8n and minus 40n. So we're going to get minus, we're going to add those two together, and we are going to add minus 8 and minus 40. So we have minus 48n, and we have minus 48 as a number. equals minus 64 n minus 64. Okay, so again, why don't we collect the variable terms on the left, and we'll collect the numbers on the right. So first thing we're going to do is we're going to add, to get rid of the variable term on the right, we're going to add 64n. So we have to add 64n over here. Okay. And over on this side, I'm going to start doing a little bit of shorthand here rather than doing all the individual subtractions, but you understand what we're doing. Those two will cancel out, right? 64n minus 48n, and that's going to leave me with 16. Positive 16n minus 48 equals minus 64. Okay? And so now what we're going to do, we want to get the numbers on the right. We're going to add 48 to both sides. So we're going to say plus 48 over here, plus 48 over here. And again, these two will cancel, and we will be left with 16n equals, and minus 64 and plus 48 gives me a minus 16. And we're left with n equals minus 1. Now I want you to notice that what started out as a fairly complicated problem ended up with a very, very simple answer. And the thing is that if you just stay methodical about one step at a time, don't try to leap to too many things at once, you will work out with an answer that will be good. All right. Okay, this one over on the right side is a little bit more complicated, but not much. So we have minus n. First of all, let's collect the terms on the left, or we can go ahead and do that. And we got minus n, we got a minus 4 and a minus 7, so that becomes minus n minus 11 equals, and we'll go ahead and distribute the parentheses here, each one. And so we got minus 3 times minus 1, which gives me a minus 3, and minus 3 times minus 5n gives me a positive 15n, because a minus 3 times a minus 5 gives me a positive number. And then we'll distribute the next one, minus 8 times n, and minus 8 times 7 gives you minus 56. Excuse me. Okay, on the left, we don't have any terms to collect because we only have two terms, a number and a variable. Excuse me. On the right-hand side, we have both numbers and variables to add. We've got a minus 3 and a minus 56. If we add those, we will get a minus 59. And then we'll add our two terms that are like terms with the variable. We have a plus 15n minus 7 or minus 8n, which gives me a plus 7n. All right. Now what we can do is we'll go ahead and write in our minus n here and our minus 11 here. All right. Now on this one, just to be different, show you that it works both ways, I'm going to go ahead and collect the numbers on the left and the variable on the right. And so first thing we're going to do here, let's add n to both sides. We'll take this minus n, we'll get rid of it. We'll add a plus n. That means we're going to add a plus n over here. These will cancel. And I'm left with minus 11 equals minus 59, okay, plus 8n. All right. And so now what we'll do is we'll get all the numbers on the left. We're going to add 59 to both sides. So we're going to add plus 59 here and equals plus 59. Not equals, I'm sorry, back that up. And then we're going to add plus 59 over here on the right. And that leaves that. And what do we have here? Well, this minus 59 and plus 59 will cancel, which is what we want. 59 minus 11, I believe, is 48, right? Positive 48 equals, 8n. And as you can see, what we end up with is a very, very simple solution after we get all through with this. And we'll divide both sides by 8. And we will get 8 into 48. And we get n on the other side. Okay, and you can probably do that math in your head. Okay. But it's 8 times 6 is 48, so we'll get 6 equals n, and we're done with that one. Okay. I'm going to do one more problem for you, just because it's somewhat of a special case, and some people are not real familiar with how to tackle this. All right. It's a very simple problem. M plus 7 equals 7 plus m. Okay. How do we deal with that? Well, we do the same thing. What we do is we collect the variables on the left and the numbers on the right, but you'll see what's going to happen is we're going to end up with a kind of a funny looking solution here. If we subtract m, let's collect the m's on the left, so we're going to subtract the m over here, and that would leave us 0 over here, and guess what? It leaves us a 0 over here, and we're left with 7 equals 7, which is true. If I wanted to go ahead and subtract 7 from the left so that I get rid of the numbers on the left, guess what happens? I just end up with a solution that says 0 equals 0. And you think, well, what does that mean? Well, what it means is that no matter what number I put in for m, it works for all real numbers. So what we could say then is the solution here is all real numbers. And the reason is I can plug any number I want to in for m. I can plug 5 in there, and I get 5 plus 7 equals 7 plus 5. I could plug 222 in there and say 222 plus 7 is equal to 7 plus 222, and it would still work. There is also a situation that occasionally occurs where you will have a number on the right and a nothing on the left, 0 equals 7 or 0 equals 5. And what that does is tell you there is no solution, okay? Because you know that if you came up with a solution such as, and I'll just quickly make a quick note here. Suppose you had done this and your solution came out to be that your variables all went away and you came up with a solution that said 0 equals 8, okay? If you get this, the indication there is no solution, okay? Because this gives us a falsehood as the solution to our equation. And so in this case where you get 0 equals 0, right, you have all real numbers for your solution. If you get this case, you get no solution, okay? And that concludes this presentation.